Rusted Gate was a very unique project in that the project team, Bruce Ritchie leading that project team, reached out to me at a very early stage in the project, which is critical to the success and the ability for a project to take advantage of all of the early design incentives that the program has for projects like this. The project is special in that it had really aggressive energy goals from the start. The project owner was already driven to do some amazing energy efficiency upgrades on this project. And to be able to sit at the table and support them and talk through some of their ideas was so much fun. And as you can see on this slide, Rusted Gate really took advantage of a lot of the latest and greatest technologies out there. They decided to do some high efficiency envelope measures. They went ahead and installed a variable refrigerant flow system with heat recovery. This also includes an dedicated outside air unit with heat recovery, split system heat pump, which is part of that VRF system, and then a hybrid heat pump water heater, which is a great technology and it's really starting to show its face in some of the other construction projects that I've worked on over the years. What's wonderful is, like I said earlier, because they jumped in and got engaged really early, they were able to capture all of those early design incentives. So this is that sit down at the table. Let's chat through what your project is going to do. Let's talk about energy efficiency in all of the different systems that the project will be building out. So these systems are mechanical or they're envelope or whatever it might look like to save energy. So we were able to sit and chat through with the project team all of the goals, which is, like I said earlier, is key. And then they were able to get that incentive. They also were able to capture some incentives for their energy modeling work, which is wonderful because that energy modeling is given to the project team at a stage where it really drives some of the energy efficiency decisions that they make. It helps you understand the pros and cons of a particular measure that might be implemented, the cost versus the benefit of that measure. So it helps drive that decision. They also opted to add in solar. Not only did they build the building amazing and energy efficient, but then they added solar. And this is why we get to call this project Path to Net Zero, because this building is producing enough kilowatt hours from their solar system to pretty much offset the consumption. And while we don't have all the numbers in and we don't know exactly what that looks like for this building, it's looking really good. You know, they put in a lot of solar systems. As you can see on this slide, they were able to capture a lot of energy efficiency incentives. So you can see that number, $85,900 in Energy Trust cash incentives. This money goes back to the project team. This helps bridge that financial gap between standard systems and the energy efficient systems. With that, something that is often not thought much about is how the building will perform for the future years. And so because of these energy efficiency measures, this building should save close to $26,000 a year in energy costs. That obviously reduce the overhead. It makes it easier for this building to continue through the generations and be maintained and kept up. That means that we're looking at about 101,800 kilowatt hour savings a year with 85.86 kilowatt solar capacity. And then, of course, 109,800 kilowatt hours are generated from those 85.86 kilowatt solar system. So again, this project is not only beautiful, but it's very energy efficient. And they really took the time to think through the future and what it would look like for this site and how would the generations in front of them maintenance and keep this project up. So thank you so much for attending this meeting and being open to some of these really fun and cool ideas about technology and how to go about applying it to your project.
Thank you, Anjali. Well, now let's get to hearing about this project. You're probably as excited as I am to get into the details. And we have a wonderful panel today to really discuss each element. We have Joanne Shannon here, the Executive Director at Rusted Gate Farm. Tell us how it all came to be, because it took a true vision and a commitment to the sustainability to make what you're seeing here possible. We also have Bruce Ritchie, principal architect at Bruce Ritchie Architect. And so if you are as impressed with the design as I am, just in the background, I was like, lighting controls, yes. Each element, we're gonna hear more, probably even more exciting elements than just the lighting controls in the bathroom. But we also have Robert Niels here with PAE Engineers. You know, it took a lot of engineering excellence to pull this all together. And then we have Jamie Kavanagh, and, you know, with true South Solar, and we have some other true South Solar members here today too. So if you're excited about solar, and when you walk around, I mean, that's just you can't miss it, but it really looks just seamless with the environment. So I'm like, our audience, I can't wait to hear more. So without ado, thank you. And let's get into our presentation today. Joanne.
Thank you. Thank you very much. I also want to mention Dave Ross with Adroit is here today. He was our project manager, and actually is the one that cracked the whip and kept everything on time and on budget, which is such a pleasure. So I just want to acknowledge his. And if there's any questions about construction, then you too. So this is really fun and interesting. Thanks for venturing to Central Point to our, what we refer to as our headquarters. How many folks out there have been to Rustic Gate Park? Okay, so I'll start with a little story about us, and then talk about how you know, how we came to include this system in this new building. I will be short and brief, and I have prepared remarks, so it'll be succinct and not ramble for your benefit. All right. So our story, Rustic Gate Farm starts with our founder and startup gift funder, Christy Walton, philanthropist and impact investor. And with the help of her sister, who lives in our neighborhood, this is a very personal story, brought to her attention and had the foresight to, in 2013, to purchase the first two properties that comprise the farm today, 29 acres, out of our current 1,000+ acres that we've amassed for our efforts, all exclusive farm use property. We refer to them as the family names today, Castor Farm, Hanson Farm, and you're sitting on Strauss Ranch. These are generational farms that were being underutilized. Families wanted to move out of their properties. There were no buyers, except in 2013, the hemp speculators came to the Rogue Valley. And the two properties we purchased, that were purchased first, were under that pressure. Christy and her sister, so-called, put a stake in the sand and said, no, not these properties. They're going to stay EFU, and they're going to stay as productive agricultural property. So that was the very, very, very beginning of that. And then this property came up, and the three property owners were most motivated by the condition that they would be used for food, whether for animals, plants, food, and not cannabis products. Not a value statement, just the best use of the property for the community here in the Rogue Valley. Rustic Gate Farm as an organization was then born as a nonprofit 501c3 to provide the structure to operate the efforts that were started personally into the future. So that's who we are today. We have a 5-member board of directors, community members, and Christy herself. And we have been in operation, it'll be 6 years in April, the first 2.5 or more completely dedicated to addressing deferred maintenance on farms. I think those of us live here know that can happen. And some farms like to, they call it collecting repair parts, but it can be 5 acres of basically junk. So we spent some time correcting that. I mean, on all the acreage we had, imagine the septic tanks and sewers and fencing and everything you can imagine. So our mission that we developed and that we live by today is through sharing outcomes of experimentation with traditional, alternative, and innovative farm practices. Rusticade Farm intends to identify a mix of income-producing activities that will increase average farm income, promote environmental health, and enable long-term financial security for small farms. So 100% dedicated to making farming viable, continuing that in the Valley through our work. And a few examples of our programmatic work. We have a trial of a perennial wheatgrass underway on one of our properties. That is, we're experimenting with it as a forage for animal feed. It has only ever been grown for grain. It is a patented seed called Kernza out of the Land Institute in Kansas. We are using it as a commercial application, not as a trial for forage. And the benefits of this plant is it has an extremely deep taproot when it grows, and it's a perennial. So it's part of our drought resilient, climate resilient agriculture work that we're experimenting with on the farm. In addition, switching away from an annual grass, which is what most hay farmers do right now, to perennial reduces tillage, annual tillage, thereby sequestering more carbon and by normally maintaining a perennial, and it also reduces labor costs. So there's less tending to it, so to speak. And we are in our third year, and each year we have a greater yield. We're going to find some more acreage, but we have 16 acres under trial right now. And we'll be able to, we think after 3 years into 4, have some information to share that has some time frame of yield, nutritional value, moisture value, and all the things people care about for their animals here in the Valley. Other climate resilient work is we are applying the science and research supporting ways to reduce enteric emissions, aka methane, from livestock, and transitioning our grazing pastures, all of them, to intensively managed practice, which is consistent with heading in the regenerative agriculture direction for our property. We also partnered with a local processor to bring USDA inspected slaughter back to the Rogue Valley for the first time in over 30 years. There is a mobile hybrid, kind of a hybrid mobile unit on our property. We're the landlord. Montgomery Meats is the operator. So it provides an exciting opportunity for our ranching community, because with inspected meat, you can sell direct to consumer, you can sell to restaurants, and you can sell to grocery stores. So finding another outlet for the born and raised animals here that people have here in the Valley, then selling live calves off to a feedlot. So that's the beginning of that program. We also have, we're into education. We designed, along with the Valley School, which is a Medford school district charter school for middle schoolers. We wanted to do the middle schoolers because no one else wants to do the middle schoolers. So we have a place-based education program with a highly immersive curriculum here on our farm, down at another site just down the street, that takes, so the kids can take the field work, like being in an 8-foot pit, studying soil and moisture content, take that information back to the classroom, and in the math class learn how to use an Excel spreadsheet to plot data, to enter data, create a chart from that data, and then sort of like in English class, they'll learn how to write a narrative about their work. So it's pretty cool. This is the first year we're in this program. It's a 3-year program. So we're so excited, and it makes our younger staff really excited because they're working with young people, the next farmers, hopefully. Anyway, so that's, so as I said, we're a 501c3. We fund our work with gifts, donations, grants, and income from our farm. There's information over here about us and an envelope if you want to take it with you and make a consideration. And for those of you that haven't seen our store, please stop in. We sell our own beef, produce, fruit. We recently added some added value products of bone broth and some tallow. So we keep close tabs on all the statistics for our products so we can see what the margin is on them. And if it works for us, then we can share it with other farmers and ranchers on how to make more money out of their cattle. So how did we come to include 100% renewable energy in this new building? Pretty easy. Our founder has been committed to solar for 25 plus years. Her husband stepped up and bought a controlling stake in First Solar in the late 90s. So imagine what that's worth today. But that was a sincere, heartfelt commitment, knowing the family. So all buildings that our founder has been involved in, that I've been involved in over the years, all of them have solar panels at a minimum. It's just part of the DNA of being involved. We're on our own as an independent organization now, so we have this system. So it didn't take a lot of convincing, because part of this building would have at least had panels on the roof. So we were partway there already. And then Bruce and Angela came in and presented to us the opportunity to go for net zero. And before Bruce retires, he wanted that on his resume. So it was hard. I was a little resistant, and primarily because of the cost. And to go from some panels to full system and a full building is a big, and I had done a capital campaign. I had a certain amount of money, and it was like, okay, but through the incentives, and then further looking at, and we received what the Rural Energy for America program out of the USDA went from 25% to 40% capital grant toward the cost of the system. So we were awarded those funds, which made, now we're talking, so we made the commitment, but along the way, we had to secure some more financing for the project. So we had that. And then the only other piece of funding that we're waiting on is that during the last administration, federal administration, nonprofits were never allowed to get tax credits for doing solar because we're nonprofit and we don't pay taxes. So in the last 4 years, that was what came out of that was a tax rebate. So we have our rebate request in along with several other nonprofits that I talked to, and we're all waiting to see what may happen given that circumstances have changed in DC. So we'll keep you posted on that. So for the long run, we know we've made absolutely the right decision to not only have clean energy, but to have a reduced energy bill in the future for a nonprofit. So what we leave behind is something that is more doable, because that kitchen will only accelerate over the years. So we're very excited and very happy. And once the payback is done, we're free. So there's it.
Thank you.
Mm-hmm.
That's actually really
This is mine?
yeah. I mean, you essentially just brought that up. I have runs on the floor.
So now we'll move on to Bruce and to tell us a little bit about design. And we have some pictures here, which, Jan, we're looking at. Is this the original barn? No. Oh, okay.
Inspiration.
Inspiration. I'll let you speak to these.
Go back. Yeah. So I'll give you a quick background of me. I grew up in Douglas County, rural Douglas County, and 40 acres. My father and grandfather were building contractors. So I was around that all my life. The ranches and farms with their barns and water towers, prune dryers, even hop dryers, everything. The 40 acres that I grew up on, when my folks bought the property, it was a plum orchard that had been taken out, and it had a turkey barn and a hay barn. So I was always just growing up just fascinated by those buildings. I guess in their proportion, their the scale of everything. So when we were under construction here, The supervising electrician, we were actually in this room one day, and he said, "How did you come up with this design?" And so then I gave him my little, history story of where I grew up and what I was exposed to and everything. And just said that, when you're designing a building, as many of you designers and architects know, you have to start with the function. But in my case, because of the rusted gate and the fact that we're out here in the rural area with farm buildings and ranch buildings around, to try and keep what I thought would be appropriate architecture. In this case, vernacular agriculture. So the slides that I've collected, actually I've collected them over the years, are almost all from Oregon and most of them from Southern Oregon, because I wanted to at least have some examples to, work off of a vocabulary. So, which one? Right. Yeah. So again, just trying to give you a sense of what I was thinking about. And these barns, the one in the upper left, Kirkendall was in Ashland. But these represent just what appeals to me in terms of their scale and their proportion, and what I kind of used as inspiration for the design. Again, more of these barns. The turkey barn that was on my folks' property was a 2-story long barn. I don't think I've ever seen one again like that. We have, even believe it or not, hop dryers and prune dryers. The top two are hop drying sheds, and the bottom two are prune dryers. And again, just part of my inspiration for this. I've always loved towers, and the water towers are what comes to mind to me, and these are examples that are here in Southern Oregon. And probably the most obvious one would be grain elevators, and the reason those are in there is you'll be able to see in the design was inspiration for one component of this building. So when you take all of those and kind of explode them and show where some of those architectural shapes and sizes come from, and then that's with this rendering, wanted to show you the different sort of parts and pieces and how they kind of slid into place to put everything together. At the beginning, because we didn't know what would grow in the building, so one of the things I was trying to do was sort of this cartwheel configuration, was thinking, well, if say the farm store needed to grow, we could add on to the end. If this multi-purpose room needed to expand, we could grow. The production area we'll see later. So that was part of the notion of how those different components came together to create the design. And again, using some of these aerial photographs just to show the context of, we're out here in the country surrounded by the farm and ranch buildings and that whole environment, and trying to show how these different building components will actually blend in, even though they're grouped together as one building, but still trying to show the individuality of each of those parts of the building. In the floor plan, then I think you can, I can't do this over my head, but again, the multi-purpose room you can see in the lower left, and the gallery up front where you came in, and the farm store up at the top, and the production area up in the right-hand north corner. And you can kind of see how in a floor plan, how those different parts and pieces come together. So obviously, trying to do net zero energy, you have to have a building envelope that's as energy efficient as possible. And so part of that is balanced with okay, what are the resources that are available? What are, the skill of the trades, what they're used to in terms of construction types and methods. And I mean, I could have gone many different ways, but in the end, this just seemed to make the most sense, which is basically you have the wall framing. When you add up all the components, including drywall, plywood, sheathing, airspace, fiber cement siding, which is not very resistant, but you're about at an R23 for a total wall. And we have the R15 rigid insulation, the whole interior, the exterior perimeter of the slab, because this building is slab on grade. The roof structure, again, just trying to have, the character of these sort of my agricultural building influence, to have lots of vaulted spaces and as few, flat ceilings as possible. So the slope rafters with a combination of foam and batt insulation. So you get up to right around R44. And everything, you're trying to do all the tricks. Jeff Lamascus was the project super, you're making sure every crack and crevice is foam sealed, doors, windows, everything. We've got, the blue skin membrane, which, which is like vapor permeable. If you're familiar with all these different membranes, they come in all different flavors, and you want one that can breathe, that has a little bit of moisture migration through it. You don't want to, paint it in so everything's trapped. And so there's a lot that goes into it, but again, it's trade-offs. So you just go through the process and what makes the most sense for what you're doing. And as I'm sure all of you have seen, the complexity of getting all of this in the ground and in the right place, and so that the rest of the work that comes on top of it will flow nicely. And to Dave Ross's, he's their group, their workers, everybody. I think they said that they really enjoyed coming out here. It's because of the setting, to come out here and go to work every day. But just the way everybody worked together on the project, and Jeff, the project superintendent, said that everybody really got along well, which you always love to hear. And again, trying to do things to make everything tight. You can see with the membrane under slab membrane, and all the attention to detail to seal everything around every penetration and up the edge, the rigid insulation. So it's all of these things, even though they might not contribute directly to energy conservation, but just for the life of the building. And then here's my grain elevator. So I talked to Joanne and said, gee, we're doing this building way back off the road, and it's not easy to see what's going on. And part of my thought was, you need something that grabs people's attention, so they look over and say, what's that? And maybe there's some interest in going up and seeing what that is. And so that's part of what the drive was for the display gallery tower. And again, when it's all covered with just raw plywood, you can see those sort of my vernacular agriculture shapes as they come together. And the issues initially were, because the Almeda fire and everything that had happened before, was make sure everything sort of meets the fire-wise materials in construction. So that was what led to the fiber cement siding, the board and batt siding, the Corten metal roof, the aluminum clad windows and everything, the landscaping around the building. So it's a pretty, there's no overhangs, there's no adding, ventilation strips, anything for any embers. So it makes it a pretty defensible building. And in this picture, the blue skin, the membrane, and you can see the fiber cement panel going up, and the rain screen strips and everything. And then just a close-up of that to again see the detail and care that went into flashing around the windows and the doors, and it's so important. It's just part of what makes the building work and last. And here it is, sort of in its blue stage when it was completely wrapped up. And then obviously what Jamie's company did with the solar, and we had the notion to do not only the roof mounted panels, but ground mounted panels and pole mounted panels, with the notion that the pole mounted panels could also act as shade structures for picnic tables and other things, because Rusty Gate has a lot of school kids, bus loads, and if they're out here in the summer or sunny weather, that they can congregate out here under a little bit of shade. And there's Jamie's True South Solar's folks up there doing what they do best. So this is what you see today. Again, just trying to show you the different ways the parts and pieces went together. During the modeling, it was determined that the way the envelope, everything was put together, it was 36% better than a code building. So, and that's before the PV panels. That's just the building is 36% more efficient. And the wood, about 90% of the wood is FSC certified. That's the glulam beams, the framing lumber, the exterior windows and doors. Those are CR Pacific, and all of their wood they use is certified. Again, from the Firewise, there is a flat roof area that's a Class A TPO membrane, and so it's very robust. Inside, that's a shot at the exhibit gallery out there, which is, the ideas for that are still coming. And just a little group pictures of the different parts and pieces. The farm store, that's a nice little story. Their barn over there had a dismantled barn that was being preserved for something. And when Joanna and I went over there to look at it, and I was going, oh, wow, that would be great in the farm store. And so that's where it ended up. And there's actually someone's name and date carved in there, 1923, so it's 100 years old. It did have some issues with the cow odor that had been preserved in the wood. So Dave's guys, they had that out, airing out for 2 months, 3 months, 3 months, and then treated to make sure you didn't get the full barn effect when you went into the farm store.
Right,
Yeah,
right.
yeah, you don't want to smell, what, when you're trying to buy meat. And the commercial kitchen. So that's a kitchen that they can grow into, because we were trying to plan for what might come down the road in terms of classes, demonstrations, their own production, having possibly other, outside people come in and use it. So if you go in there now, it might look like a little cavernous, but I think that's the one space that you'll definitely grow into over time as they find more uses for it. The Motley Crew.
I love it.
So Dave, Jeff Lemaskis, me, and Joanne. After I labeled that, I thought, no, this looks more like ZZ Top plus one. So, PAE, Robert's firm, with the mechanical, electric, plumbing engineers. Conrad Brown was a mechanical engineer. Structural Solutions, Jason Prinz was the structural engineer. Mark Dew was the civil engineer. Mark was the geotech. Carrie Kincairn was the landscape architect, and obviously Dave and Detroit built it, and Jamie and True South Solar did all of the solar components. So that's how it happened.
If I could just add a quick.
Yeah.
This was very masterful working with our special land use, exclusive farm use. We are an exclusive farm use zone, and this is a commercial building in association with agriculture. So as you walk around, you may say, well, why are there only 3 offices? Or, it's not, we had to adhere to the requirements. This is an agricultural area primarily. So this room was called nothing. I mean, not to be dishonest, but to call it an official classroom or community center would not be allowed under the land use code. So we wanted to honor that, but sometimes as we grow, boy, we could have a lot of offices, but you can't have an office building in an ag zone. So we were very careful to honor the code, but allow ourselves a little room to grow and to do what we wanted to do. And they were very understanding of that. So, yeah.
Yeah, one thing you learn as designers, architects, it's very crucial how you label spaces, because you can, and I have made those mistakes where I labeled something that was just because that's sort of what it was, but because the building official looks at it a different way, you go down a whole different path.
Wonderful. Thank you, Bruce. We'll hear from Robert with PAE.
Yeah, awesome. Yeah, thank you, Bruce and Joanne. As you can tell, with the initial vision of the building was so strong that, when we were onboarded to the project, there was a lot that we would typically do with the energy modeling efforts that we didn't really have to go through with this one. They already knew that they wanted to have solar on the building, that they wanted and designed and built a very high performing envelope that was right at the project inception. So a lot of what we would typically do with energy modeling in the early stages, was not required for this project. So we got to just start right away with a solid set of philosophical, goals on the project, and really just get straight into the energy modeling, which was great. It really helped to inform the mechanical, electrical, plumbing systems right off the bat, which was really, a really great thing to jump right into. This overview, I'll kind of step through it, but this is ultimately what we ended up with, and I got some slides on the energy modeling side as well. But yeah, just right away, like having such a high performing envelope really set the stage for a solid, energy model. The time that we were onboarded already, as you can tell with the vernacular of the building and the shapes and the form was so strong and established that we were able to just start with a 3D model right away, full geometry, and get in there and really suss out the mechanical, all the systems. And what we ended up with here, starting with HVAC is, right up here on the roof for the heat recovery system. So we have a dedicated outside air unit out there with heat recovery in it. And it was, I guess just backpedaling a little bit, the all electric component was also, established before, as we were being onboarded as well. So we had both of those working in our favor here. So the DOAS unit has heat recovery, and essentially what's happening is all the exhaust from the building is being routed up through that heat recovery. So it preheats and cools the outside air coming in. to kind of help offload the load of the heating and cooling system, which in this case, what we ended up with was a VRF, variable refrigerant flow system for the heating and cooling. And so those work together to heat and cool the building and bring in fresh air and, odor reduction. But the efficiencies that we were gained with the, routing the exhaust through that heat recovery really amounted to really help drive down the unit size. The plumbing, the hot water heating as well was an efficient use in this case. Over here, I don't have the floor plans, but in the mechanical room where we have the hybrid heat pump water system, that's also where the refrigeration units are. So they've co-located those together. So as the kitchen, the commercial kitchen, the refrigeration is off putting that heat, we located it inside and co-located with that hot water heater. So there's a transfer of energy. So as it's off, giving off the heat, the water heater is taking that and using that to heat the water, which was done. I can jump back to the floor plans here in a second, but it was done in that corner of the building, a real efficient use there. Let's see here. Another kind of goal that we had was to lean into the passive component as much as possible, especially with the gallery space in the tower. So where we ended up there is, operable windows and a ceiling fan up in that space. And the operable windows are both high and low. So depending on the time of year and what the conditions are outside, you can open one or both of those and get that stack effect in there, which also helped kind of heat and cool that space, that kind of open space by the gallery. So yeah, and then on the electrical side, and I'll let True South and Jamie and True South talk about the solar, but on the electrical side, the whole building is outfitted with high performing LED luminaires throughout. And the lighting control is really, I think, where we get the most benefits from that is there's not a centralized lighting control system, but instead every space has its a dedicated, what I call room controller solution, including the hallways and some of the public spaces, so that every space can operate independently. Each office can have its own, controls. If it's not occupied, the lights can come all the way off. And then spaces that are occupied, all of them are outfitted with photosensors, so we can really take advantage of all the great daylighting that's been provided in the building. And then, yeah, definitely, right off the bat, we knew full solar on the building, right? So the building is 100% outfitted with solar on the roof. And that's really where the energy modeling effort came in. So with such a great input from the beginning, we built the 3D model right off the bat, really to understand kind of, we used local weather data, and we're able to really get a good understanding of where we were going to stand at. And you can see here, like what Bruce was saying, that the building just through the envelope performance was performing 36%, I believe, better than code right off the bat. So really was already off to a great start. So most of the energy modeling effort was actually surrounding the commercial kitchen. With such a huge, potentially huge block load for the building. The bulk of the rest of the building was very, very low energy as far as like the usage case. So the kitchen is really where we spent most of the time getting into the model and really understanding how we could best right size all the systems, and including the required PV. And so we did some, to kind of help with what Bruce was saying with the goals that the kitchen could grow over time. We did some sensitivity studies and kind of just looked at it as like, okay, if it was just 1 day a week versus a full 5 day a week kind of operation, what are we looking at? And we really spent a lot of time with Rusty Gate and the design team understanding basically at a per piece of equipment level, what is that anticipated usage gonna be? And so we went back and forth quite a bit, kind of understanding how it was gonna be used and how it was gonna grow over time, to essentially right size that energy model, and kind of figure out what the operational impact was gonna be on the building. And what we ultimately ended up with was essentially kind of averaging that and kind of had assumed like a three day usage case on the kitchen. knowing very well that throughout the year you might see it higher in certain phases and lower. So we kind of not only looked at it on a weekly kind of average basis, but also what does the annual use look like? What are the different seasons? Like, are we going to see high production at a certain time? And we just took all that information together, and you can see here we have like the high case and the low case of a 5-day and a 1-day usage case for the kitchen, and that kind of had its own its own output as far as the PV was concerned. And we knew with either cases that we would exceed the rooftop capacity. And that's where we started to work with ETO and Rustigate and the design team to figure out, okay, well, what opportunities do we have to get some off built-in PV? And that's where we ultimately ended up with some of the canopy structures outside to really get that case. And the final design, this is kind of what we ended up with the final design here. So the project uses approximately 50% less energy than a code build-in. And I think the number actually got a little bit, right off the bat was 36, and then when we implemented the other energy measures, really brought that down quite a bit. And that's essentially where TrueSouth Solar was able to come in and help kind of offset what what the model was showing to pull off the net zero design. This is a breakdown of the different loads throughout the building. The cooking being the highest, but space heating obviously being another high component as well. Just some more information on the final design there. Yeah, then that's where TrueSouth kind of took over.
Well, as you can see, my job was done. We did it all. It's not too often that I get to come into a project where this much work has already been established and the usage is understood this clearly. So it was very exciting to kind of be able to come in and be like, okay, if this is exactly what your building is going to be using, I can build this. I can tell you what I can do. And so that's kind of where this started off. And I'll even back this up a little bit because I remember years ago, our first meeting over at their other facility, coming in and sitting down and being like, okay, let's meet everyone, let's talk. And that's when we established that everyone was from here. We all love this project because we love the idea of having this space, working with this farm that's not only doing things for the community, but kind of being this leader in, you have this new agricultural product coming out and what you can tell other local farms. And it was kind of this magical little moment of we're like, this is why we're all here. And so now we are here in a whole different setting. But this team right in front of you did all of these steps. And then I got to come in and put beautiful panels all over the building and cover it all up. So I'll kind of start off a little bit with, I think everyone's probably familiar with how solar works, but just a real quick, easy, basic. We have our solar panels that comes down into an inverter and it services the whole building. And whatever energy we're not using, because ideally you're overproducing, goes back out onto the grid. And that's what we call net metering. And so then you're getting credit for what you're not using at certain times of the day or year. And then you get to pull on those credits when winter and storms and all of the time the sun is not producing exactly what you need. So Oregon has a great system set up for us that way. And this is how we're able to kind of take advantage of being a net zero. Otherwise, we would need to store all of the energy in a battery so that we could use it at times of the year when we're not producing as much. So just to kind of understand the basics of solar. I joined this team knowing we're going to run out of roof space. And so this was kind of this preliminary design of here's this beautiful building, here's slowly as we kind of went through the space of what panels we had available, what could we fit on the roof, then we started looking at the ground. And so here's where I'm going to talk a little bit about the types of solar. We have a traditional ground mount solar, which you do see out front. This is typically in open fields, spaces like that are not size constrained. It often can be elevated in a little bit different way, especially if you do want animals to have access to, or you need a little bit more access for cleaning, vegetation management, things like that. You often see this large scale. So we're going to see big, huge systems out in fields, gigawatt This is like mass production you're going to see in this kind of style, but also in small farm settings as well. Next style is what we call a pole mount. And this is what we're utilizing more of like a shade structure kind of way. And this allows you, there's a couple reasons to do this. One, we can elevate so people can be underneath. Two, we can also elevate for cleaning vegetation. And also it kind of condenses. So voltaics, you'll see that a lot of times so that animals can pass underneath. There's different techniques this can be put into. This also works really well when your terrain is not flat, because otherwise in a traditional setting, you know, we can kind of move slightly with the topography. However, here you can see even on a pretty steep slope, we don't have to cut into the grade now. We can actually just focus on one spot and actually put more panels up. So just kind of showing you the different ground options. And then this is more of a traditional roof, which you kind of see everywhere. So in this setting, we had to use them all, and we knew we had to use them all. And so how we used them all was the fun pact. And there came challenges because we wanted to be able to have more of an educational aspect. So that's where the picnic tables came in. And then there's also the part of where we have to meet codes of where you shouldn't be allowed to go because there is working electrical equipment, and how we tied that in to a working farm. You know, that's also something that we had to be very aware of. So it was a process that the whole team had to take on. But in the end, that's what we knew we had to accomplish to get this net zero. Now, to do that was all about fundraising too. So for a year, I think we spent applying and putting all the information we needed for certain grants. And we did apply for the Blue Sky grant and were not awarded. And we did apply for the USDA grant, the Rural REAP grant, and we were awarded. And that was very exciting. That is a small business, agricultural. We are in the area. They have changed the areas that are eligible now. So we were able to get in on that, which is amazing. But to go through those steps of explaining our story and how that translates and what this money would help us do was massive, because it allowed us to get to that net zero. But it is a process, and luckily solar goes on last, and that's unfortunately usually when it gets cut, but it also is what allows us to keep applying and making sure that we can fundraise until and when we have that chance, we're still able to move forward with it. So having those funds available, like Joanne mentioned, we have the ITC as well, and it's a huge benefit. Nonprofits have never been able to take advantage of the financial things that small businesses can. And so this was a huge shift, and it is, I'll bet, very tedious to go through the IRS sometimes. But I have had successes doing it, and it just takes a little longer. So if you're willing to put that time in, which is a project that's net zero, is all about time. I mean, we have to put care in every decision we make, and it's worth it. It's financially worth it. So in the end, what you're going to see is the 3 different styles of solar all in one. We gave it all. We're showcasing everything. The pole mounts allow people to actually be kind of invested and involved in the solar. You get to see underneath what the panel technology, the electrical work, what it looks like. Those pole mounts are movable, and I should say that they're adjustable by tilt. So the farm can take advantage seasonally if they want to adjust that tilt, which can help production numbers. In our modeling, we didn't do that, so that if they do, that just helps them, you know, because it's a lot of work as well to manage. But they are beautifully located at 180 degrees south, so we didn't have to do much in that. And that's, I'm sure, not exactly by luck, but it made a lot of sense when it came to solar. And then you'll have our roof line, and you'll see we put south, east, and west, all producing angles for you with solar. We have put solar panels on our north-facing sides of certain buildings, but you're going to need to be aware of your angle and your tilt, because then we're shading ourselves most of the time throughout the year. You do that usually knowing that in the summer months, you're going to get enough sun. In the winter months, you're probably not going to produce on those panels. So they're not the most efficient, but if that's the only space you have, and that's what's going to get you to your goals, and then we can help accomplish that. Yeah, I mean, I had a set number, and I knew what I needed to build to produce that. And that's where we came with this setup. I mean, I worked pretty close with the engineers here to make sure that we understood the annual load. And you know, we have an estimated production numbers with solar. There is a variance because of weather. There's a variance that's going to happen because we live in a smoke world now. So that's always something we have to consider. And because there's ways to overproduce, you do not get necessarily paid extra to overproduce. You are essentially sending that power back out. However, it's good to have a little bit of a buffer, knowing that if we have a smoky summer, our highest producing months, that we have some excess available. Our system can keep producing for us. I will say the only thing we haven't really talked about is equipment selections. The biggest thing I can say here is, you know, we selected the panels for two reasons. One is we wanted to do an all black panel for kind of that look of cohesiveness between the two, the upper and the lower. And then our inverter is the biggest piece of equipment. That's the thing you'd want to talk about. In most commercial settings, you want to use a string inverter. We're not dealing with any kind of shading. Shading is what's going to affect your production. And then in most residential settings, you're going to see a microinverter. What that means is each individual panel is producing on its own and is able to, if it's one shaded, all the rest are still working. In a string inverter, if one's shaded, that string is down. So we are using a string inverter in this case. However, because we have so many roof lines, we have so many different array styles, we are using what we call an optimizer. And that means that each individual panel now works as if it was micro. So that allows us to optimize all of our panels year round and not worry about shading. It's not always necessary in a commercial setting, but in this particular commercial setting, it's beneficial. So there's no way that we're going to really, you know, one corner shaded in the morning, which is normal, and that happens. The rest of the panels can still take advantage of the sun. So that was kind of our big decider factor when we were looking at equipment as well.